Alright students, this is actually on both AB and BC tests for this week. This temperature question in an office building. I'm going to be jumping back and forth between Desmos and this page because I think graphing it on a calculator and showing is not as clear. So, we're going to solve this thing. Part A. At what time will the temperature first reach 70 degrees Fahrenheit? I would strongly encourage you to write out your function. The function specifically is t, and I want to know when is t of x equal to 70. And on the AP test, if you're ever asked about equality of two separate functions, you can solve, but this is really hard to solve. I'm going to write this out, but I actually don't know how to solve this question super easily. I could, probably, but it would be pretty tricky. So 73 minus 14 cosine of pi times x minus 3.4 all over 12. This is the equation I'm trying to solve. I'm just going to graph both sides on Desmos. You would just graph both on your calculator and see where they intersect. Equality, in this case, is equal to intersection. So graph both of these and figure out where they intersect. Let's check where this happens. I've graphed both of these here, green and purple. You'll have to change your window for sure, but the first time they intersect, 8.575. So I'd say, okay, then in this case, x equals 8.575. But the question says to the nearest half hour. At what time does that happen? And x is time since midnight. So we're thinking 8.5 hours after midnight, so it's about 8:30 a.m. 8:30 in the morning. And then part B is the exact same question, just with a different temperature. So go back to your Desmos graph or your calculator. Instead of graphing 70, I'm going to graph 77. And look for that intersection. 10.507. Which is just 2 hours later. So it's not anything too crazy once you write it out. But so part B, my solution, I would definitely need to write this equation still. When does 77 equal t of x? At about 10.5 hours. 10.507. Or at 10:30 a.m. C and D are related to both A and B respectively. So part C says right here, what is the cost per day if the desired temperature is 70? Essentially, we're just going to use this C function. This is a cost function based on two things. Number one, starting time, and number two, desired temperature. So T naught is a desired temperature and X is a starting time that AC is going to kick on to try and keep the building cool. So for part C, my desired temperature is 70. That's this one. And my starting time is actually the thing I got from part A, so it's the 8.5 number. So I'm just going to integrate this from that 8.5 to 18. And this is a case where if you're typing it into your calculator, I would really recommend using the VARS menu, so the VARS menu, to pull back up t of x here, instead of typing that whole thing into your function. So put that in your y2 probably, or y1, wherever it is, and then reference it on your calculator. If you still want to practice that, let me know, we can. But on Desmos, I labeled the same thing. Here I labeled this as t of x for the previous part, just like you would have it labeled as y1 or y2, and then I integrated t of x minus 70. So let's check this number again. The intersection point was 8.575. That's my lower limit of integration. And so I get 18.266 dollars. And of course we would need to write this all out. We'd say, okay, C of 8.575 equals 0.16 times the integral of 8.575 to 18, because it's going to shut off at the end of the day, minus 70 dx. And then we get, what did we get, And what is the unit here? The unit is dollars per day. I think this is good enough reasoning. You showed what integral you typed in. You showed where your number came from. I think you're probably good. Part D is a little bit different. We have to just change two things. We have to change our lower limit because the AC is going to kick on a little bit later, and we have to change our desired temperature. So this is now 8.788. I'm not going to write that whole thing out, but here's the cost per day. But that doesn't answer the question because the question says how much money is saved. So we just subtract 18.266 minus 8.788. Okay, $9.48. So they save $9.48 per day if your temperature is set 7 degrees higher. Kind of a realistic, interesting question that you could do on your own home or apartment that would, I think, be really eye-opening. So this is just question 1. I'm going to split this up now because A, B, and B, C tests are different, but this is on both of them. So this one's a little bit tricky, but definitely something